Strands PNG Compression, due to its use and goal of compressing PNGs. The goal is to losslessly compress PNGs further than they already are. This is useful for gaming sprites and textures, due to the limited amount of unique colors in the compression algorithm allowed. This is explained further later in the video. While regular lossless compression fully relies on repetition and placing placeholders in repeating spots, my software relies on a unique pixel list, an index pixel list, and a little bit of repetition. The unique pixel list states each unique pixel in the picture and puts them into a list. Then the index list is a list of indexes or positions of a pixel on the image that are in the unique pixel list. So for example, if pixel A is in the image 50 times, one pixel A will be in the unique list once. And then each pixel A that showed up in the original image will then be in the index list as an integer, and that integer correlates with the position of pixel A in the unique list. This unique list and index list will be used later on while decompressing the PNG file. The unique list is the list of all unique pixels in the image. These pixels will be used in the compressed image or strand at the beginning. These unique pixels are needed for the use of the index pixels. The index pixels are the image because there are an equal amount of index pixels to pixels in the original image. These index pixels are converted from pixels to integers. After decompression, these integers are used to find the correlating unique pixel in the unique pixel list. Then the program puts the image back together in the same way it was before. So let's say we want to compress this picture of a penguin I made. It's a simple pixel art that can be used in a game, video, or anything of that sort. So let's just open up the app and input the directory to the PNG of a penguin. Now the penguin has been compressed into a strand of unique and index pixels that are then put all together into pixels on the new strand image. The strand image is basically the zip file or the compressed version of the original file. This strand file is made up of first the unique pixels, and then the index pixels. Each index pixel is one integer or index for the unique list. Now this may not seem like it will compress the original sprite by much, but it actually does. It compresses it by a whole chunk of it. This new image is only a half of the original image's size on this computer, and it only took 0.6 seconds to compress that image. That may seem like a lot of time to compress one single image due to having to repeat and repeat using the software over and over again, but I believe that this software will get better over time. People will contribute small changes to it that will allow it to grow and prosper as a new compression algorithm. Now let's say we want to decompress the image. First we need to input the directory or path of the compressed image which is in the encoded folder. Now, once it's decompressed, we can see that the practice program penguin is now in its original form, and it optimized the image even by a little bit, so now the decompressed version of it is even less than the compressed version, which may seem counterintuitive, but overall I'm really happy with this result, since it resulted in 2.37 kilobytes in the decompressed image, which is a lot less than the original image by itself. The use cases of the software is pretty simple. It's either used for optimizing sprites and textures in games, or it can be used for optimizing websites with the PNGs and pictures. But the main rules of the software is that each image cannot have more than 1,000 unique pixels in its unique list. This is because of the way that the index list works, and you can see how this happens if you look at the code and you understand it. But right now, as far as I know, it can only go up to about 1,000 in unique pixels in the unique pixel list. And also, the image must have some repeating unique pixels to compress. It can't just be like only unique pixels. It has to have some index pixels that are repeated, just like regular text file compression.